All right, this is lesson 13, inequality relations. So, symbols of inequality. Inequalities compare two or more values and represent a relation between the values. So the open side of the inequality symbol always faces the larger of the two numbers. If an inequality is only less than or greater than, the circle on the graph is open, so it's not filled in. If an inequality is less than or equal to or greater than or equal to, then the circle on the graph is closed or filled in because that number includes that specific number. So if it's x is greater than or equal to 4, it would be 4 filled in because it includes 4 in anything that's greater than that. Okay? So example number 1, graph the following inequalities. X is less than 7 and b negative 7 is less than or equal to x. So I'm dealing with these two right here. Okay, I'm dealing with less than or equal to. So this solution, plot the point, fill in the circle if the inequality is less than or equal to or greater than or equal to, and then determine which way the arrow points by reading the inequality starting with the side that begins with x. So x is less than 4 reads x is less than 4, and negative 6 is greater than or equal to negative 6. Draw the line and arrow. So x is less than 7. So I start at 7. X is less than 7. So my arrow goes towards my negative numbers. I have negative 7 is less than or equal to x. Okay, so in this case, I actually want to read it as this. X is greater than or equal to negative 7. Okay. So negative 7, and then it's greater than, so it's toward my positive numbers. Solving linear inequalities. Solving linear inequalities is similar to solving linear equations, which we did last lesson. The only exception is when multiplying or dividing by a negative number, you must flip the inequality sign. So therefore, less than becomes greater than, less than or equal to becomes greater than or equal to, greater than becomes less than, and greater than or equal to becomes less than or equal to. Okay, you get the idea. So if I want to solve 3x plus 6 is less than 12 and then graph the solution. So I solve the inequality as if it were an equation. Since you're not multiplying or dividing by a negative number, I don't need to do anything with the inequality sign. So 3x plus 6 is less than 12. So I subtracted 12 from both sides, which gives me 3x is less than 6. I divide both sides by 3. Again, I'm dividing by a positive number, so I don't need to flip the sign. So I get x is less than 2. Okay. So here's 2. It's an open circle because there's no equal sign underneath, and it's less than, so I'm going this way. Okay. Example 3, solve 8 minus 4x is greater than or equal to 16, and then graph the solution. I want to solve the inequality as if it were an equation. So I have 8 minus 4x is greater than or equal to 16. I subtract 8 from both sides, so I have negative 4x is greater than or equal to 8. Now I'm dividing by a negative 4. This is the key part right here. Okay, when I divide by that negative 4, I have to flip the inequality sign. So my greater than or equal to becomes a less than or equal to. 8 divided by negative 4 gives me a negative 2. So I fill in my circle at negative 2 because it's got an equal sign underneath and it's less than. So it's going this way. Compound inequalities. Compound inequalities consist of two or more inequalities that are separated by and or or. So each conjunction has its own properties as outlined below. So and requires that both statements are true. Show where the graphs are the same. It doesn't actually always happen. So sometimes you might come up with a no solution. The graph looks like a dog bone. So example, x is less than 8 and x is greater than or equal to 4. Compound inequalities involving and can also be written as 4 is less than x is less than or equal to 9. And statements are not always true. So for example, x is less than 3 and x is greater than 5. A number can't be less than 3 and greater than 5 at the same time. Therefore, the inequality is not true. Or statements requires that one or more of the statements are true. So graphs may be apart, together, or overlap. So example, x is less than 8 or x is greater than or equal to 4. So graphing compound inequalities. And the graphs of compound inequalities involving and show where both statements are true. So both statements have to be true. Both statements are true. Okay, which is where the two graphs intersect. So I'm looking for where they overlap. Okay, so I want to graph x is greater than -4 and x is less than or equal to 6. Okay. So x is greater than -4. So I have from here, here's -4 and it's greater than, so it's going this way. X is less than or equal to 6. 6 is a filled in circle and it's going towards the negative numbers. So the graphs intersect between the two lines. So they intersect between -4 and 6. Okay, so that's where I get this. -4, I leave it as an open circle. 6, I fill in the circle, and anything in between them is what I'm looking at. Okay, so or, the graphs of compound inequalities involving or show whether either statement is true, therefore the graphs may intersect or continue in opposite directions. So basically, you're going to graph everything. Okay? So example 5, graph x is greater than 4 or x is less than or equal to -3. So x is greater than 4, open circle, greater. X is less than or equal to -3, closed in circle, less than. So I combine the graphs, I get this. I have up to and including -3, and then nothing here. And then at 4, it's an open circle and everything above 4. All right, solving compound inequalities. Compound inequalities are two inequalities that are combined by and or. To solve these problems, separate the two inequalities at the conjunction and or, and solve each separately. Use the steps below to solve compound inequalities. Step 1, split the compound inequality into two simple inequalities. Step 2, solve each simple inequality. And then step 3, combine the simple inequalities into one compound inequality. So example 6, solve and graph the solution set of 4x plus 2 is less than 8 or 2x minus 4 is greater than 12. So to solve this inequality, I divide the problem into two parts. The 4x plus 2 is less than 8 and the 2x minus 4 is greater than 12. So 4x plus 2 is less than 8, I solve and I get x is less than 1.5. And then 2x minus 4 is greater than 12, I solve and get x is greater than 8. Okay, so therefore x is less than 1.5 or x is greater than 8, and I go ahead and graph that. So here's 1.5, less than or greater than 8. Remember, because it's or, they don't have to overlap. Solve, for example 7, solve and graph the solution set of -18 is less than 3x plus 6 is less than or equal to 21. To solve this inequality, divide the problem into two parts. Recall that compound inequalities without words are equivalent to and. So I have -18 is less than 3x plus 6, and I have 3x plus 6 is less than or equal to 21. So I get -8 is less than x, and x is less than or equal to 5. So I have -8 over here. So this was x is greater than -8, so up to this, and x is less than or equal to 5. So this is my solution set. Solving absolute value equations and inequalities. The three cases for solving absolute value equations and inequalities are if the absolute value of x equals n, then x equals -n or x equals n. If the absolute value of x is less than n, then x is less than n or x is greater than -n. If the absolute value of x is greater than n, then x is greater than n or x is less than -n. We can solve equations and inequalities involving absolute values by writing compound sentences that represent both of these cases, as shown in the examples below. Remove the absolute value symbols and write the equation or inequality with one case equal to the positive value and one case that's equal to the negative value. So I have solved the absolute value of x plus 2 equals 4. So I have x plus 2 equals 4 or x plus 2 equals -4. Okay, I solve for both. So x equals 2 or x equals -6. Okay, -2, -6, or 2, -6. Okay. That one's pretty simple because there's an equal sign. Okay, so solve the absolute value of 4x plus 12 is less than 24. Since the inequality is less than 24, the arrow is facing the side with x. The solution uses the and conjunction. So I have 4x plus 12 is less than 24, and 4x plus 12 is greater than -24. So when I solve this, I get x is less than 3, and x is greater than -9. So -9 is less than x is less than 3. Okay? So that means that my solution is between -9 and 3. All right, 10. The absolute value of 4x plus 12 is greater than or equal to 24. Since the inequality is greater than 24, the arrow is facing the side without x. The solution uses the or conjunction. So 4x plus 12 is greater than or equal to 24, and 4x plus 12 is less than or equal to -24. Okay. When I solve, I get x is greater than or equal to 3, and x is less than or equal to -9, and I go ahead and graph that. So if you're unable to solve an equation or inequality on a multiple choice test, you can solve the inequality by substituting the answer choices for the variables until you find an answer choice that makes the equation or inequality true. Okay. And go ahead and work on the exercises below.